I'm Ming.
And I'm Kevin. And we're the Mythbusters.
So today, our topic is corrosion. This is defined as the deterioration of metals due to oxidation or other chemical processes.
In this video, we will be focusing on rusting, which is a common form of corrosion.
What's that?
That's a very good question. Well, rusting is the formation of ferric oxides due to oxidation in moisture.
Okay, so here's a little experiment you can do at home to test the effects of rusting. So what you want to do is get a clear plastic bag filled with water and also a nail with no rust on it. So what you want to do is just take the nail and just drop it in the bag and leave it for a few days. So we're just going to come back and check on it later. Okay, done. So it's been a few days and we're just here to check on the progress of the nail. As you can see, there's some brownish red color developing, and this is a result of the iron reacting with the water. So that was just one effect that corrosion has on a metal. Another effect is pitting.
What's that?
Good question! Pitting is the form of small holes on a surface of a metal as a result of localized corrosion. When oxides formed by oxidation do not firmly adhere to the surface of a metal, such as iron, flakes start to fall off easily. This causes pitting. Extensive pitting eventually causes structural weakness and disintegration of a metal.
When we break down rusting chemically, we find an electrochemical process which involves oxygen and an electrolyte. When rusting occurs, it takes the form of one of these three hydrated oxides. For significant rusting to occur, all three of these hydrated oxides have to be present, and the air humidity has to be over 50%. So, now going back to this nail, we can use our chemistry to find out how the rust forms. When a droplet of water with dissolved oxygen comes in contact with the iron oxidizes in this equation. Now, if the pH is higher, then the hydrogens will combine with electrons in this equation. And if it is lower, then H2 gas forms. When iron corrodes, the pH in the water rises. This causes an increase in hydronium ions and a decrease in the hydrogens. So to sum it all up, the visible iron rusting that we can see is the formation of insoluble iron hydroxides through this equation.
Many parts of the city are connected to large bodies of water, which we gather our water supply from. When these water supplies are contaminated, it can be a large hazard. One way this can happen is due to the effects of corrosion. When metals such as iron or steel are already corroded away and are in contact with water, it may pollute the water supply. This can affect the organisms residing in that body of water or the humans that have direct contact with that water supply. In addition, every year, millions of dollars are spent fixing corroded buildings and bridges. This affects the economy of many countries who see the effects of corrosion.
Now that we've seen some of the larger scale impacts of rusting, we find that it is actually a large issue that impacts much of society. This is why it is important to look at ways to prevent rusting. We will focus on four main methods: galvanization, cathodic protection, painting, and bluing. The first method we will look at is galvanization.
Galvanization is when a thin layer of zinc is coated onto the iron. First, the existing rust on the iron is removed by sulfuric acid. Then the iron is dipped into molten zinc so a small layer stays on, or the iron could be covered with zinc dust and then baked to have a small layer of zinc. The resulting iron is called shearodized iron. Galvanization protects from oxidation and the actions of moisture. It is extra effective because even when the zinc is broken or pierced, it gives protection because the zinc would react with the moisture first. The second method of corrosion prevention is called cathodic protection. This was invented in 1824 by Dr. Humphrey Davy. This is when iron is submerged in an electrolytically conducting environment, such as water, which is an environment in which there are enough ions to conduct electricity. An electrical charge is run through the water to disrupt the chemical processes of rusting and stop formation of iron oxide. It is recommended that a professional does this. The third method is painting. This is when a layer of paint is coated onto the iron, which gives a physical barrier between the metal and moisture. This is an effective method, but it also needs regular maintenance. Also, whenever paint chips flake, the moisture is accumulated to that one area, making it corrode faster than normal. The final method is called bluing. This is commonly used on firearms and other steel household appliances. First, all the oil is removed, and then it is polished by a bluing product. Bluing gets its name from the blue-black color that the appliance takes on after applying the bluing product. Bluing blocks the moisture from coming in contact with the steel and also acts like a barrier.
These methods are all very effective when used in the right situation.
Throughout this video, we've given you some general insight on the topic of corrosion. Firstly, we looked at the physical effects that corrosion has on a metal.
Then, we broke it down chemically.
After that, we looked at the larger impacts that corrosion has on the environment as well as the society.
And lastly, we looked at some of the possible methods to prevent it. I hope that you've taken away something from this video, and also that you find corrosion a topic worthy of attention. So that concludes this week's episode of Mythbusters. That was good.
One way the contamination of water can happen is when we